So today we're looking at rational functions. Can someone tell me what a rational function is? Well, we should know that it's a function. Okay, what else do we know about it? Kind of. What does it mean to be rational? Yeah, whole numbers are rational.
Yeah.
But not all rationals are whole numbers. What's the special qualification in order for something to be rational? Yes.
It's expressible by a fraction.
Yeah, we have to be able to write it as a fraction. Which is also true when we start adding in variables. So it's a function of the form, our function, f of x equals n of x divided by d of x, where n of x and d of x are polynomials. So, one of the simplest forms of a rational is our reciprocal function, which is just 1 divided by x. So it tells us to find the domain of the reciprocal function and discuss the behavior of f, which is our y values, near any excluded x values. So what do we need to find first? Find the domain. So, are there any values that x cannot be? Why? Because we can't have a 0 in the denominator. So we have x such that x cannot equal 0. So then it asks us to discuss the behavior of our y values that are near that value. So near 0. I can't plug in 0 because it gives us an error. But we can plug in stuff that's around it or close to it. So what's a number that's close to 0?
1.
Sure. What do we get if we plug in 1? 1. Now, is there a number that is nearer or closer to 0? 0.5. And if we plug in 0.5, what do we get? 2. Alright, can we get closer to 0? 0.25 or 0.1. What do we get if we plug in 0.1? What about 0.01? What about 0.001? So if we're looking at our x values, so as our x values are getting closer to 0, what's happening to our y values? They're going up, they're getting bigger. So what would we say they're going towards? Positive infinity. Are those the only numbers that are close to 0? What other numbers are close to 0? Negative numbers. So all of these numbers are on the right side. We also have to look at our left side. So if I looked at, say, -1, what do we get when we plug it in? -0.5? Are we going to continue in the same pattern as our other one, just with all negatives now instead?
Yes.
Yeah. So I'll get negative 10, negative 100, and negative 1,000. So this time, as my x value is getting closer and closer to 0, what is our y value getting closer and closer to? Negative infinity, because we're getting more and more and more negative. Questions on that? Alright, does anyone remember what these types of values are called? Numbers or values that we're allowed to get really, really close to, but we can't actually get to.
Does it start with an I?
No,
Okay.
just with an A.
I don't know that.
Yeah.
Asymptote.
Yeah, they are asymptotes. Alright, so who wants to be a volunteer? I need two. Otherwise, I just pick volunteers. And you get voluntold.
I'm not gonna go for the one thing. I'll
The
just stand
skull.
up there like a idiot.
Well, all I need to do is stand, so. Kyler, go for it. Go stand. Kyler, go for it. Colin, come here. Stand right here.
Oh.
So, if you were standing, so turn face Colin. So if I have two people that are wanting to high five each other, and there's a good distance between them. So if Colin walks half the distance between him and Kyler, where would we end up? Okay. Then could he go another half the distance? And could he go half more of the distance? And then I could make it super awkward if I really wanted to. But I won't.
You got volunteer.
But then, right, our hands could go half the distance and half the distance and half the distance, right? But would they ever actually reach each other if I can always take another half of that distance?
No.
Because I can always find a smaller fractional of a distance between the two of them, right? Thank you guys. Good job.
Candy.
Sure.
Oh, really?
So that's what is called one of our mathematical paradoxes, okay? Because theoretically, the two people would never actually touch, right? But realistically, we know that they do. But that's kind of the concept behind our asymptotes. They're these imaginary lines that we can get infinitely close to, but we'll never quite reach. Does that make sense? And we actually have two different types. We have vertical asymptotes. Is it melting? I mean, it's been sitting by my computer. You want a different?
Yeah. I think he deserves two.
You might pick a non-chocolate thing.
Is it also milk?
So our vertical asymptote is this imaginary line. So it's going to be the line x equals a such that f of x or our y values are going to go towards either positive or negative infinity as x goes towards whatever our a value is. So for our last one, what was our a value? What was our x getting closer and closer to? 0. So it would be at, our asymptote would have been at x equals 0. Now, our horizontal asymptotes are going to be similar, but they're horizontal. So it's going to be the line y equals a, such that as x goes towards positive or negative infinity, f of x, or your y value, is going to go towards your a. So here are some examples. On our first one, this has a vertical asymptote and a horizontal asymptote. It's kind of hard to see, but if we were to extend this graph like horizontally, it never touches it, but it is going to get like really, really, really close. So basically our y value is going towards 0 as x goes towards positive or negative infinity. For our second one, it doesn't have a vertical asymptote, but it has a horizontal asymptote at 0. So again, if we were to extend that graph, it would be getting closer and closer to 0. And then our last one, again, has both. The only difference is this time, both sides of my asymptote, my vertical asymptote, are going towards positive infinity. So they don't always have to be opposites like the ones that we saw. Now, notice that our asymptote lines we draw with like dotted lines because they're not actually a part of our graph. They're like an imaginary line that help us to describe the behavior of our graph because we know our graph is going to get really, really close to them. Does that make sense? Alright, so our next page is going to give us some ways that we're going to find our asymptotes. So we know what they look like, hopefully, on a graph now, but we need to be able to find them given an equation. So if I have f of x equals n of x divided by d of x, so now, when we looked at our first example, we said that 0 was what it wasn't allowed to equal, and at the end, we said that x equals 0 would have been our vertical asymptote. Agreed? So how did we find that number from our equation? How did we know that it was 0, that it wasn't allowed to be? Because it was on the bottom. So in general, whatever's in the bottom, so d of x, if I set that equal to 0, that'll give us our vertical asymptotes.
You do the top one for horizontal? No.
Sorry, what was the question? You don't know.
I don't want to say that you better make me feel bad.
No, we should never make someone feel bad for asking a question.
It wasn't that. It was not that. I don't really like it too much.
You said with the horizontal one, the n of x equals 0.
Not quite. Now, we will end up setting our n of x equal to 0 because that's going to give us our x-intercepts, but it doesn't give us our horizontal asymptotes. It'd be nice if our horizontal asymptotes were that straightforward, but they're not. So we have to look at our degrees. So remind me, what is the degree of a polynomial? How do I know what the degree is? Which exponent? The biggest exponent. So I'm going to say, well, let's let little n be the degree of n of x, and little d be the degree of d of x. So then basically there's three possibilities. The first one is if our little n is bigger than the little d. So basically, like if I had something like x squared divided by x. So I have bigger stuff on top than on the bottom. That means that there is no horizontal asymptote. You just don't have one. You don't always have to have a horizontal asymptote. And you don't always have to have vertical asymptote either. And our next option would be is if little n is less than d. So like on the first example that we looked at, what is the degree of just 1 if there's not any x's? Not 1, because then I would have an x to the first power. So if there's not any x's, it would be 0, right? So the degree of the top was 0, the degree of the bottom would be 1, so the degree of the top would be smaller than the degree of the bottom. If that is the case, then y equals 0 is going to be your horizontal asymptote. And then what's our last option? They equal. Now, if that's the case, what we're going to do is it's going to be the leading coefficient of n of x, so basically the first number of the top, divided by the leading coefficient of d of x, or the bottom. So you'll just divide those two things, and that's what your number would be. Questions on that? Going to give us the steps that we use to graph our functions in general. There's a lot of steps. None of the steps are necessarily hard, there's just a lot of them, okay? However, I'm going to give you the abbreviation that I use, okay? So let's not freak out, just because there's a lot of words. There will be. Alright? So, it says 7 steps. I like to condense it to 4. Okay? So, the way that I like to describe it, so it says let f of x equal n of x divided by d of x. Okay, that just means it's a rational. I have two things being divided by each other. Our first step, it says to simplify if possible. What it means by that is we're going to factor. So we're going to factor and simplify if we can. Now, our next two, so 2 and 3, they go together. And basically what we're looking for on both of those are intercepts. Okay. On the next two, so 4 and 5, those steps, we're looking for the asymptotes. And then on 6, we're going to plug in test points, and then we're going to graph it, which is pretty straightforward. I don't think we need a step that says graph it, if that's what it's asking us to do. So your abbreviation is F-I-A-T. So fiat is what you have to remember to make sure that we complete all of the steps for the graphic. Like I said, none of them are necessarily hard. You just have to remember to do all of them. And so that's why I think it's helpful to kind of have the abbreviation as like a little bit of a breakdown. Questions on our steps? Okay. So then let's look at an example. We have f of x equals 2x minus 1 all divided by x. So what's our first step? Factor. Now, does this function factor the top or the bottom? So 2x minus 1 or x? No. So we'll just say not applicable. Or can't do it. Or don't need to. Or whatever makes you happy to put it. We don't have to factor it this time. So then what comes next? F-I, so intercepts. Now we have two kinds. We have x-intercepts, we have y-intercepts. And we need to find both of them. So for our y-intercepts, what do we do to find the y-intercept? Nope. Because if I'm on my y-axis, right, which is what it means to be a y-intercept, y can be any number, but what does x have to be? 0. So what do I want to do? Set x equal to 0. So we would have y equals 2 times 0 minus 1 divided by 0. So what happens? It's undefined. So that means that we don't have one. Now, for our x-intercepts, what do we want to do? Set f of x equal to or y equal to 0, yes? But for a fraction, which part is allowed to equal 0? The top. So that's why we want to just set our top equal to 0. And then solve. So we would add 1, divide by 2. What do we get that x equals? 1/2. Are we all okay with how I've gotten all of the points up to that part? Yes? Okay. So then what's our next step? We need to find the asymptotes. And again, we have two different kinds that we talked about. We have vertical asymptotes and horizontal asymptotes. And we need to find both of them. So how do we find our vertical asymptotes? Set the bottom equal to 0. Well, this time I just have x equals 0. We don't have a whole lot of work we have to do. So that means that our y-axis is going to be a vertical asymptote, which is why we don't have an intercept. Now, what about our horizontal asymptote? What did we say we need to look at? Our degrees. Okay? Now, if you can't remember the whole like N and D thing, okay, because it's hard for you, basically what you want to look at are your first terms on the top and the bottom. So like here we would have 2x divided by x. Agreed? So what does that reduce to? 2. So that means that y equals 2 would be my asymptote. Okay. So then I'm just going to start plugging in some stuff, okay? Because remember, we want to do lastly our test points. I'm going to go ahead and graph some of this because it makes it a little bit easier to pick our test points. So we have an x-intercept at 1/2, a vertical asymptote at 0, and a horizontal asymptote at 2. Now, if we recall back to when we did our quadratic inequalities, remember we had to draw the number line, and then remember that we had to pick test points in each of the little sections on our number line in order to see if the inequality worked or not when we did quadratic inequalities. You remember that? Vaguely. We're going to do something similar here. We're going to draw a number line. And we need to put in, so remember last time they were called critical numbers. This time it's just anything that crosses or is on our x-axis. So we have a vertical asymptote at 0, and then we have an intercept at 1/2. So those are the two numbers that I have on my number line, which is our x-axis. So then basically from there, we need to pick a number that is in between each of those spots. So something that's to the left of 0, something that's in between 0 and 1/2, and then something that's bigger than 1/2. So what's something that's to the left of 0? -1. So then we're going to take that, and we're going to plug it back in to our function, and what do we get? Do we agree? 3? Okay, so then what's a number that's in between 0 and 1/2? 1/4 or 0.5. So what do we get if we plug in 1/4? -2. And then what's something that's to the right of 1/2? 1. And what do we get when we plug in 1? That's 1. So then I'm going to plot those 3 points. So -1, +3, 1/4, -2, and 1, 1. Now, it doesn't look like we have a ton of information on our graph. However, we can think about, what did we do that for? We can think about our asymptotes kind of like black holes. So can anyone tell me what a black hole is?
It sucks more.
Yes, so it sucks in all energy, light, matter, everything gets sucked into the black hole. And our asymptotes are similar because they're going to basically suck our graph closer and closer and closer to that line. So while I only have 1 point over here on the left side, I don't really need any more points because we know that as it goes to the right, it's going to have to get closer and closer to this imaginary line. And then as it goes to the left, it's going to have to get closer and closer to the horizontal line. And it's going to be really similar, bless you, for my other side. So that's what our graph would look like. Questions on that one? So we're going to do one more together. So we have x squared minus 9 divided by x squared minus 2x minus 3. So again, what's our first step? Factor. factor, which this time does our function factor. Yeah. So our top is a difference of squares, so what is it going to factor to? Do we all remember our difference of squares formula? So remember, it's just x and then adding and subtracting whatever the square root of your last number is. Okay, so then what is our denominator factor to? So what multiplies together to give me -3, that adds together to give us -2.
-3 and 1.
So it's to factor, and then the next part of that is to simplify. Do I have anything that simplifies? My x minus 3's. Which means that really what we want to look at for this function is x plus 3 divided by x plus 1. Now we're going to come back to the factor that we reduced out here towards the end. But for right now, we're just going to work with the new function that we got. So then what's our next step? Your intercepts. So what do we want to do to find our y-intercepts? Plug in 0 for x, right? So we have y equals 0 plus 3 divided by 0 plus 1, which is just 3. Now, what about our x-intercept? What do I do for that one? Not plug it into the top, but set our top equal to 0. So we get x equals -3. So then we have our asymptotes. Now remember our asymptotes, to find our vertical asymptotes, we set our denominator equal to 0. And to find our horizontal asymptotes, we want to look at our leading numbers. So we just get y equals 1. So then I'm just plotting the stuff that we found. And then our last step is going to be to do our test points. So what are my values this time that are on my x-axis? So my point is at -3, and my asymptote is at -1. So then again, we're going to plug stuff in. That's in each of those. So let's say -4. So what do we get if we plug in -4? Remember, we're plugging it into our reduced one. You would have -1 divided by -3. So we get a positive 1/3. And then what's the number that's in between -3 and -1?
Or
-2 So if we plug in -2, we would have -2 plus 3 gives us 1. -2 plus 1 gives us -1, so we get -1. And then lastly, what's something that's to the right of -1? We could do 0, but notice that we already have a point at 0, so we don't really want to do that one again. So we could plug in, let's say, like 1 instead. So what do we get for f of 1? 4 divided by 2, which is 2. So again, I'm going to take, so -4, positive 1/3, -2, -1, and then we have positive 1, positive 2. So again, just drawing my graph to get closer and closer to our asymptotes. So our graph would look something like that. But we reduced, okay, our x minus 3, right? Now recall back. Is that still a restriction for my function even though we reduced it? Yes, because otherwise we can't put equal signs, right? The equal signs work as long as x does not equal 3. So that still has to be a restriction on our graph. So it's not an asymptote anymore, but it will be a hole in our graph. So anytime that we have a factor that is reduced, it becomes a hole in the graph instead of an asymptote.